Alright, let's go over example 26, shall we? Alright, here it is, I put it up on the board. So we've got to solve this differential equation. dy dx is negative 3, y subtract 2, all over 2x plus 1, x plus 2. It says find the particular solution, okay? Remember I mentioned that in the previous video. And it tells us the boundary conditions when x is 1, y is 4. So I've just written that up there just to remind myself of that, okay? Because that's going to be important. So what we're going to have to do is we're going to have to separate the variables with this. We're going to have to integrate both sides. And at some point we have to substitute in x is 1, y is 4 to find out what the constant of integration actually is. Okay, maybe just have a go at separating the variables first and then get back to it. Because that's what I'll do in class, to be honest. I'd normally have this question up and say, right, 2 minutes, just separate the variables for me and then we'll see what we've got. Okay, so maybe just do that. Okay, so you unpause the video now, hopefully. Put the y minus 2 over to this side, okay? So you have 1 over y minus 2. Okay, now my advice is keep the negative 3 there. There's no point in putting numbers onto the other side, okay? Just keep them where they are. So the negative 3, and it's better that way, isn't it? Because otherwise you have a fraction third. Yeah, so keep the negative 3 there. Okay, so we'll have that on the left hand side, and on the right hand side we'll have negative 3 all over 2x plus 1, x plus 2, and then dx. Okay, happy with that? So the dx over there, this stays where it is, negative 3 stays where it is, and then the y minus 2 over there, and then just integral both sides. Okay, good. Okay, and as before, we've got 2 integrals to find. Okay, we've got to find the integral of that, which is easy. It's a natural log, of course, and then the integral of this. Do you remember how to do that? Partial fractions. You've got to be quick. You have got to be quick. If you didn't spot partial fractions, sorry, but you're too slow. I mean, I know I'm sounding harsh at this stage, but you're too slow. You've got to get on it, okay? Because in the exam, you've got to know what to do. Because you know, each method of integration takes a while to do, doesn't it? Partial fractions, once you get going, it does take you a few minutes to work out. Okay, when it's a separation of variables question, it takes you a long time to do. Okay, when it's a substitution question, when it's a by parts question, no matter what question it is, once you start doing it, it takes a while to do. But if you're just sitting in the exam thinking, what do I do, what method is it? You're wasting time. Sorry to be harsh, but that's the truth, okay? You're going to know instantly what to do, okay? Reminder, if it's a fraction, algebraic, and you can factorise the denominator, partial fractions, okay? Right, I've done the partial fractions on a separate board because I want to try and get the solution up into one single board space, okay? So, yeah, here we are. So, right in the that integral on the right hand side is this. Okay, those are your partial fractions, a over 2x plus 1 plus b over x plus 2. Hopefully you're happy with that. Okay, and then here you've got a x plus 2 plus b 2x plus 1 equals negative 3. Again, hopefully you're happy with that. Okay, and then substitute x equals negative 2. You should get b equals 1. Work it out, okay, but you do. And when you put x equals negative a half into it, you get a is negative 2. So that gives you the values of b and the value of a. Okay, is that all right? Happy with that? Okay, good. All right. I'm just going to leave that there for the time being then. And if you're not happy with it, for goodness sake, just rewind the video and pause it, because you've got to be, okay? Because if you can't get past that stage, that's it, the question is dead. Okay. So, look, should we integrate that now? Yeah, why not? Because in the exam, if you know how to do it, you'll get the marks for it, aren't you? So in the exam, there's no point in just writing out integral this until you're ready to go with that. So just work this out, okay? And my advice is, kind of like what I did here, say don't break up the whole question, just put your work in for the partial fractions on the side if you want, or just do it down here and then continue with the integral in it. So, hopefully that made sense. So the right hand side is natural log y minus 2, okay, equals, and then integral of, and it's this, isn't it? So b is 1, a is negative 2, so we'll write this way around. So 1 over x plus 2, like that, and then it's going to be subtract 2 over 2x plus 1, okay, dx, and that's that. Okay, happy with that? Just make sure I've got it right. 1 over x plus 2, subtract 2 over 2x plus 1, good, happy. Right, I'll get rid of that now. And of course this is still the same, natural log y minus 2 equals, and then let's do this. Natural log x plus 2. I almost went for plus in my enthusiasm to get the answer, but that happens in the exam as well. Sometimes you just got to slow down a little bit. Can't help myself because I just get so enthusiastic about integrals. Natural log 2x plus 1. And should we have a plus c or plus natural log k? Yeah, as if I should ask that question. Plus natural log k. Right? Yeah. I didn't check with you, but I'm hoping you're happy with that. Okay. You know, natural log 2x plus 1, the 2 there, differentiate that, divide by 2, so they cancel them out. Okay. Now, what do you do at this stage? Okay? You've got a choice. You either put in x is 1, y is 4 now, and work out what this is, or you simplify it a little bit. I'm going to simplify it a little bit. Okay. Because I want to get rid of the natural logs, you see. Okay, it should be quite easy for you. At this stage, it should be quite easy for you to do. Come on, you've been doing logarithms for nearly 2 years now, so it should be easy for you to just write this in terms of natural logs only. So on the left-hand side, fine, and then the right-hand side, what have we got? That times that divided by that. So see how easy that was? Okay, kx plus 2 over 2x plus 1. I'm not just saying that because you're watching the screen and you're not here, okay? In class, I'm kind of the same. Can you understand why at this time of year people are like, oh God, when's the course over? I can't do anymore. It does finish people off, the integration chapter, okay? It does finish people off, okay? It's like a really, really good movie, and it's building to a lovely, wonderful climax, okay? It's like the whole movie's been building up towards the biggest battle where you destroy the Death Star, and at the end of the Death Star it's destroyed, okay? But as you're approaching the Death Star, you're like, oh my God, look at the size of that thing, you know, and it's like, yes, it's kind of like this, okay? So, yeah, Battle of Yavin, Death Star, that's like the integration chapter, okay? And the rest of the maths is like the rest of the film, which is still great, isn't it? Come on, still great, okay? But yeah, anyway, moving on. Can you see what I've done now? Okay, you can just remove the natural logarithm terms, okay, by doing the inverse logs of both sides. So you can have y minus 2 is equal to k x plus 2 over 2x plus 1. Okay. Good. Maybe now we're substituting x equals 1, y equals 4. Yes, you could put the 2 on the other side. Okay, but maybe now we're just substituting x equals 1, y equals 4 and see what happens, right? Rather irritatingly, I don't think I can fit this into one board, okay? So what I'm going to do, I'm going to use this, the other side of this, okay? And I'm going to put the working in there, okay? Because I like it and everything goes into one board, okay? So y is 4, isn't it? So 4 minus 2, that's 2, equals, and then you have x is 1, so can you see that right? If I just do it there. So you've got 1 plus 2 is 3, k on the top, over 2 plus 1, 3. That's simple, isn't it? So you've got k is equal to 2. I'm so glad I didn't waste some board space. It's not wasted, but I want to make the best use of it, okay? Just to get that k is equal to 2. Okay. So what I'm going to do is I'm just going to do you mind? I'm sure you don't mind, really. Yeah. And you know, if you're sat behind the camera saying, no, we don't need to do that, well, tough. Yeah. Let's put the 2 on the other side as well. Okay. Because I just really, really want to fit the final answer on into this space here. I don't want to run this. Normally this takes up a lot of board space, a lot of working space, okay? Just trying to fit it all on, because, you know, at the end, maybe you want to do a screenshot of the final solution, okay, and frame it or something. Well, what we're going to do with this, okay? Yeah, you can leave the answer like that, can't you? Because the question says, make y the subject, basically, doesn't it? Okay, so what was the question again? Just read it properly. It says, leave your answer in the form y equals f of x. Which that is So done. You know, in the exam, it's 4 marks. Okay. In the exam, don't bother. Just go on to the next question. Okay. But when you're actually doing this outside of exam conditions, it's nice to simplify it a little bit, isn't it? Okay. So what we're going to do, we're going to combine these. It's like adding fractions together. Okay. So we're going to just write that as 2x plus 1 there and 2x plus 1 there. Just get the common denominators. Okay. And then we'll just simplify. Okay. So you'll have 2x plus 4x. That's 6x. Plus 4 plus 2, that's plus 6. 6x plus 6 over 2x plus 1, okay? You can factorise that. Shall we factorise it? Okay, why not? As I say, in the exam there's no real need, is there? Just, yeah, y equals, yeah, that, and that's your, ooh, that's your particular solution. Okay, it's called particular because it's one particular solution that fits when x is 1, y is 4. I don't think they left it like that in their textbook, to be honest with you. No, they didn't. Okay, no, they didn't. But if you just rewrite that, okay, you should get exactly the same, shouldn't you? Yeah, 6x plus 3, yeah. That's better. Okay. You might say, why is that better, Mr. Brown? A legitimate question. Well, you know what I'm like with sketching graphs, okay? I like sketching graphs. Suppose you need to sketch the graph of what this function looks like, okay? Written in that form, it's going to be easier, isn't it? Yeah? I'm sure you could quickly sketch the graph now and see what it looks like, but it's much easier when it's like that as opposed to a mixed term, okay? Before I go, another question that I want to answer, something I'm often asked, is this. Remember at this stage when I said, right, let's integrate this and put down an answer. Okay. Some of you might have thought, well, why don't you put a plus c? You know, when you integrate, you usually have a plus c, a constant term, don't you? Why did I not put a plus c there? Okay. Maybe just pause the video and think about that, because there's a very good reason. Did you think about it? Good. Well, let's just suppose I did. Okay. Put a plus c there, then put a plus c there. Okay. Now, when I've integrated this, okay, let's not call it natural log of k, okay, let's call it plus. Now, can I call that c? No, okay, because it's a different constant, isn't it? So maybe I have to call that c1 for one constant and c2 for another constant, okay. Now, what have I got? I've got a constant on both sides, okay. Well, why don't I just put this constant term onto the right-hand side until I've got just one constant there. Okay, and what should I call that one constant? I don't know. Let's give it a different letter because it's logarithms. Call it natural log k. So you don't need to actually put in the plus c. The general rule is you don't need to add the constant until you've done your last integral. When you've got an equation like this, when you've done your last integral, that's when you can put your constant in. Okay, I'm hoping that made some sense to you. All right, and I hope you enjoyed this. Okay, I hope you enjoyed the exercise. Okay, keep going. Okay, resilience is the key term. Okay, yeah, it's tough, it's hard, but it's also a lot of fun. Very rewarding when you check the answer in the back of the book and you get it correct. Am I right? Am I right? I'm right. Okay. All right. See you later.